everyone, welcome back to another video of my operating system development. This time I'm going to talk through the boot process. I'll see how far I get. Might split it into several videos, but we'll find out. So booting my operating system, just to give a quick test on what we are looking at. Basically, I'm going to talk from the process to get from nothing to maybe up to this point here, maybe a bit less, but we'll see how we get. But yeah, as you can see, we have kind of a operating system that all it does at the moment is it runs a shell. You can run some tests, you can run some commands that I've written for it. But more detail on different commands in future videos. For now, we'll just focus on the boot process. So let's just open up a little editor so you can see what I'm doing, and bump up the, how do we do that? Yeah, let's bump up the font a little. So to boot anything off a x86 machine, which is the architecture we're looking at, there's a few different ways we can do it. We can either use a service called the BIOS, or we can use another one called UEFI. In my case, I am just going to use the BIOS for now, but in some future point I'll start using UEFI as well. There's some benefits. The BIOS is considerably simpler to do. What these services do, basically allowing some code to run to then kind of bootstrap your actual kernel to run. So it's what people might call a bootloader. Now there are various bootloaders out there already, such as Grub. Grand Unified Bootloader, I think it stands for. So I could actually just use Grub and that's the end of it. Don't need to worry about any of this, but this project for me is more educational, so I'm quite happy just to work out how things work and go with that. So for now we'll look at BIOS. So BIOS stands for Basic Input Output System. And as you can potentially guess from that name, it allows basic input and output functionality, so you can kind of bootstrap that kernel to get loaded. Examples of functions that it can do: it can read from disk, it can write to disk, it can get input from the keyboard, it can output to VGA. You can do all this. You can output to VGA as a function or directly via a buffer. In my case, I just do it as a function because I have kept my bootloader reasonably small for various reasons, and I do more of the buffer stuff in protected mode. So one thing to note there is when you use BIOS, you start in real mode. So just a small recap on x86. Modes, we have real, which is 16-bit, we have protected, 32-bit, and we have long, which is 64-bit. In my operating system, we're not using long at the moment, and so far I haven't really talked much on real mode. And that's where this video comes in. So when we start in BIOS, we actually start in real mode, and how we do that is the BIOS is a bit of code that runs before your bootloader. there are people that write BIOSes, so there's some open source BIOSes such as Coreboot and CBIOS, which kind of get around some of the proprietary stuff, but other than that, pretty much any x86 device has a BIOS of some kind, and it will allow you to basically run any operating system. So theoretically, you can get my operating system, put it on a disk, and boot it, and it will just work. So how the BIOS works is the BIOS looks over all the disks for an MBR, which is the master boot record. And it's looking for, it looks in the first sector, which is 512 bytes, 512 bytes. And what it is looking for is a magic value at the end of that first sector that looks like 0xAA55. And that means that that disk is bootable. And the first disk that it finds with this magic value, it will load up into memory. So it will load that that single sector 512 bytes into memory. Memory at 0x7C00. That is what my notes say, so that's good. We don't need that. And at this point here, it will load it into there, and then it will basically jump to that address. So it will set the IP register instruction pointer. Will be set to 0x7C00. So the IP was EIP in protected mode. Mode, man, spelling is not good this morning. It's earlier than most times I do these videos. I've got the day off today, but I thought I'd get a video out because I haven't done one in a bit. So yes, at this point, we have loaded a sector into disk, and we're basically running that code here. And if we look at my stuff, what we can see, cool, is weird like that. What we can see is we have this org MBR entry in this source boot 16, and if we look at includes, for some reason I put in an include file because I thought that would be good, but who knows. But here we can see MBR entry is 7C00, and that's the magic, and that's the size of the sector. So org basically means all addresses from this point, and the assembly code should be at that point there. So this label here, the first label, these are just constants. So this label here will be at 0x7C00. And at the bottom of this, we have this little thing here that basically up until that MBR size, which is 512 bytes, minus 2 bytes for the magic value, we basically clear the bytes, and then at which point we write our magic. Now, you might be wondering, oh, what happens if we go over those 512 bytes? What we can do is, if I get rid of this, and say times that many, and we write that many bytes. If we then try to run this bad boy, it'll give a excellent error of invalid value, and after a while you work out what it is, but you'll see here I've also printed out little things. So max size can only go up to 70 FP, and we're 70 FD, so actually like only like 1 byte off. So like, yeah, that's kind of interesting. I wonder if oh no, that's just because I do that before that. If I do that, so that's the thing there. So without this, I only have 1 byte before I could run it. Yeah, so the current offset is a lot bigger than the 7D. So A is like 16, so 7 to 16. We've gone quite a ways over, and if we don't do that, then they'll run as normal. So, what do we need to do when we're in real mode? So in real mode, we've got quite a few limitations. To start off, depending on how it's set up, you may not be able to read more than a megabyte of memory, or you might not be able to access more than a megabyte of memory, which is a very tiny amount. You can do stuff to enable to read a bit more, up to I think 16 megabytes, but that's right for this mode, because once we jump into predictive mode, we can read a lot more. We also have limited disk access at the moment. So at the moment, we only have 512 bytes of memory in disk. And so what we need to do is try and get out of real mode into protected mode, which is what I've talked about so far in previous videos. How we do that is we have to do a bunch of steps. First thing, we need to set a couple of registers like the CS and DS, which is code segment and data segment, to 0. Some BIOSes actually set the CS for you, but some BIOSes don't. So I've got this code here. Basically, as soon as we start, we do I believe this is a long jump that will reset the CS to this value, and it'll jump to this label, which is just down here. And that will set, it's a far jump. Comments, yay for the worm. So that'll set CS to 0, 0, and then down here we use our register AX to 0, and then we set DS to AX. So basically, that'll set DX. Maybe just a quick recap on registers. So we had, like, in protected mode, EAX, EBX, ECX, EDX, etc. In real mode, that's just AX, BX, CX, DX. So you basically drop the E. A bit more nuanced than that, but that's alright. The next step we need to do is make sure that we have a working stack. So what we do here is because we start at 7C00, it basically means below that isn't used. So we set our stack to be there, and the stack grows downwards, which I briefly touched on in the video about that. Next step, we need to work out where our disk is, which disk we're using. As I said, the BIOS will pick the first disk with that magic value, and that may not be the first disk. But the BIOS helpfully stores which disk it is in the DL register. So DX is the 16-bit one, and you have a DH and a DL, which is the high and low bytes of that 16-bit value. So basically 8 bytes here, and we store it into a variable in memory. And that will say which disk it is, so just be an index 0, 1, 2, 3, 4, or whatever it is. The next thing we do is we enable the A20 line. Now this is like a weird thing. Basically, historical reasons, you couldn't load more than a megabyte of memory, but how the internal components of the CPU are hooked up, the keyboard controller, yeah, the keyboard controller. The You can set a thing there that basically enables the 20th bit on the memory controller to be able to be used, which then enables you to read a lot more than 1 megabyte of memory. So we do that, and how we do that is we have not that, we're in the boot code, includes and a 20, and we just have a function that first sees whether we have it, then we enable it, then we check whether it is actually set, because that enable code might not actually do it, and error out if we don't. So here's a bunch of stuff that sets how to do it, and we mainly do it in the BIOS. The BIOS just has a function that we can check whether that we can basically activate it using a BIOS interrupt. So if we can't enable this, we will panic, because we can only access 1 megabyte of memory, and that's just not enough for my operating system. The bootloader fits in less than 1 megabyte, but as soon as we get into protected mode, we use considerably more. The next step we do is use a BIOS interrupt to set the VGA mode. So we just use text mode for now. We can actually set this up in protected mode, but it's significantly easier to do it in real mode where we can access the BIOS. So one thing with protected mode is you can't talk to the BIOS easily. You basically have to trick the CPU that you are back in real mode. The next step is we read from the disk to make sure that we have all the code that we need to basically load next. How I do this is I have a disk. Disk read sectors. That's not the one that we actually use. We use disk read. So disk read will basically load a magic value from the. We basically work out where the end of the disk is, and if we look at this, so up here, just after the boot, in between that far jump to set the CS, we actually set this magic value here, which you might wonder what this is. What it is if we look in boot 32, at the end of that we actually write a magic value, which is basically saying at the very end of our 32-bit boot code, there is a magic value, which is just that. I just made it up, but that's all right. BIOS, that one. So we work out basically where that is. We do some math to work out how many sectors that we need to read. Then we call this other function to read that sectors. There's a bunch of math. I ran into some issues. To start with, I was reading one sector at a time, but then I decided it's a lot easier if I just read the whole thing. So there is the lovely code that does all of that. So after we read the disk, and if we couldn't read the disk, we panic. After we read the disk, we stop the interrupts. We potentially should have done that earlier, but doesn't really matter too much. So in 16-bit mode, you can have a thing called IVT, interrupt vector table. Yeah, I think that's that. But we don't have it, so we just ignore that. We basically don't deal with interrupts in real mode because we stay in it very, very briefly. At this point, we set up a global descriptor table, GDT. GDT is, and if we can see how that's set up in this file here. Basically, it's a table that says how each chunk of memory should be treated, whether you can execute code in it, whether it's read-writable, whereabouts it is, like how big it is. To start with, we basically just say the code segment and the data segment are basically the same, except the code we can see has a executable flag as well, but the rest of it is all the same. We basically go from 0 all the way up to FFFF, so the most that we can do in this mode. The next step we do is we actually set a flag in the CR0 register. Now this one is one I don't think I touched on in my video about registers, but basically CR0 has a bunch of different flags saying what features of the CPU that you want to use. In this case we want to use protected mode, so you can't set it directly, so we have to move it into a register, then set it, then move it back. And you'll see here that we've used EAX, which I wonder, I think it should be something like this, but it works, so I don't know, I'll leave it. Because theoretically we're still in 16-bit code here, but we're only looking at the bottom 16 bytes, so that's all right. The next step is we basically set all the segment addresses to one address, which is the data segment. So we've got the data segment, extra segment, all these other segments that I can't remember. This one's the important one. We've kind of talked on it before. This is the offset into memory that will be used when we're loading up a data, like we're loading data from the memory, and then the code segment, which happens to be the same value, 0, but that is used for where code is. So here we do a long jump to the second sector. So this bootloader is actually quite small, fits in 512 bytes. I believe it's actually 509 bytes, and then 2 bytes extra for the magic value. Yeah, because this was saying, this was saying that our current offset was like just before. And we'll see here our second sector is just at the end of this file. And if we look at boot.asm, what we can see is we include this 16 one, and then we include the 32-bit one, and we kind of use these sections, and if we look in, I haven't looked at this file in ages, I think it's here, yeah. If we look at our linker file, we can see we start at 7C00, that's where we expect our code to be. We have the 16-bit boot and then the 32-bit boot directly after that, and then the rest of the code. And you see we also have that magic value right at the end, just in case. Originally I started with just a single file, single assembly file that gets compiled, assembled, but I went to a linked format, which I found easier. So at this point here, we jump to the second sector and at that point we will be in boot 32, and we will basically be on this line here, and this will be in our second sector, which will be 0x7E00, because we've got 512 bytes. I'm going to leave this video here because I've talked quite a while, and it's a decent spot to just stop for the day. We've talked about the 16-bit boot process up until we get into protected mode, and a future video will talk about the protected mode boot process. So yeah, that's all. Thank you very much for watching these videos, and if you have any questions or comments, leave them in the comments. You'll reach out to me, and feel free to share this video and like and subscribe, I guess is what people say on the YouTube lands. Until next time, have a good time. See ya.